Hello, my name is Rich Howard, owner of Architectural Builders Supply. This video is to bring you a closer look at the Stanley. This is their part number CB199, 4.5 by 4 in the US 1D is what this is. A fairly unusual hinge in the sense that it is a confluence or a combination of a non-ferrous base material and a 4-inch width and a black finish over that non-ferrous base material, so brass. A really smart hinge, however, really clean and smart hinge. And what I mean by smart is the following. So it's non-ferrous. This is going to be brass base material. It's not going to rust. It's going to be tremendous for exterior applications or applications where you've got humidity, or an application where you don't want steel. You don't, or maybe you can't have steel. There are healthcare applications where steel hardware is not permitted. It'd be very unusual to use such a hinge in a, I'm blanking on what the machine is called, the CT scan perhaps, something that you can have nothing ferrous around it. That would be an example, I suppose, where you'd use this. But this client is very likely specifying a non-ferrous base material because they don't want a rust sort of scenario playing out. So that makes it smart. Also, what makes it smart is it's a CB. It's a concealed bearing. Those knuckles are pretty nice and clean. There's no bearing packets. And from a distance, you would think that's a plain bearing hinge. And what's interesting is the concealed bearing hinge over a ball bearing hinge probably is about 20% more effective at carrying the load or the weight of the door, and substantially more effective at doing that job over a plain bearing hinge. Interestingly, I had a client last week get a report on a fire door assembly audit, and the auditor, or maybe my client is the fire door assembly inspector. I don't know if he's doing the work and mitigating the problems, but this opening, and there are occupancies in NFPA 80 that are mandated, at least in that standard, to be inspected annually. So fire doors have to be inspected annually in certain occupancies. It was missing a plastic door closer cover. Yes, that would fail the assembly, believe it or not. The exit device was not fire rated. It had hex key dogging, and it didn't, of course, have the label, and it's not a fire device. It also had a 161 edge prep, the 2 1/4 by 1 1/8 open. He needed a filler for that. Then his hinges were a competing brand to Stanley, but they looked like a plain bearing hinge. They were a concealed bearing just by someone else. So I sold the client the list of those 3 out of the 4 items, because we're able to provide documentation that says this hinge is a bearing non-ferrous based hinge. Well, I had him confirm with a magnet it was non-ferrous, or not brass or bronze. It can be stainless or obviously steel. It ended up being steel based, but providing information that said, yeah, that hinge, even though you don't see ball bearings, you can use that. It's a bearing, a frictionless, a lower friction coefficient type of hinge. So it's very smart in that regard as well. This hinge is going to hang a lot of weight. The fourth thing that makes it smart is the width. This is only a 4-inch wide hinge. What's nice about that is the general hinge that is used in the United States is 4.5 by 4.5. That 4.5-inch width, is that the size you need? Do you need it wider? Do you need it smaller? The point is no one really stops and says, is that the hinge I need? Most applications, many in fact, a 4-inch wide hinge where you're taking that vertical axis of pivoting and moving it towards the face of the door, just that 1/4 inch, is a smarter application. Brings the load closer to the center of the thickness of the door, or where it's being borne, that vertical axis of pivoting. Also, it is advantageous to have less projecting hardware as well. It's aesthetically pleasing too. So those 4 things together make it a very smart hinge. Then lastly, it's a heavyweight hinge. That's 180 thousandths. That is a thicker than average hinge. Let's put the caliper on that now. And then, of course, black is just the color that was selected. The year right now is 2021. 179 thousandths. That is really accurate. And black has been popular for a few years. If you go back 100 years, everyone made black all the time. It was a standard finish. Well, in the 70s, it was antique brass and, etched bronze. In the 80s, it was polished brass. The 90s certainly saw satin chrome morphing into satin nickel. The 2000s saw oil-rubbed bronze, and then Venetian bronze, and now black is the new all of that stuff. And it will probably last for 5 to 10 years. It's already at the 5-year mark would be my guess. But it's a nice finish. It's a classic finish. And the fact that it's a ferrous base material, a non-ferrous base material, that finish is going to look nice. Now, one thing that's notable about the Stanley product is that it has an exceptional clean fit and finish. The paint is clean. There's no chip marks. There's no areas that aren't covered. And what I mean is down here in the crotch of the hinge, many hinge manufacturers will get that area in here not finished very well. Some of them are awful. I've seen some oil rub bronze that my client just rejected. And you get the hinges back and you say, yeah, I would reject it too. There was all but no attempt to get that finished in here. Stanley does an exceptional job. Also, what's nice about Stanley hinges, when you take them out of the box, they just swing really nice. Other manufacturers' hinges simply do not, is the answer. What does that mean for us? I don't know. But when a client gets a hinge in their hand, they're not going to want to have to do this to get it to work real nice. So it's a really nice free swinging sort of hinge. Let's now talk about why someone would opt for a 4-inch wide hinge. Let's do so now. And what we're going to do in that regard is we'll switch to the screen view and look at the supporting documentation, but first talk about why 4-inch wide, or maybe it's supposed to be 4.5 or 5 or 8-inch wide. Who knows what it is. But we'll show you how we determine the best way to observe best practices when it comes to hinge width. Let's do that now. If you are enjoying this video, please click thumbs up or like, and also please consider subscribing to our channel. Let's move on to the rest of the video. Here is the item that we are looking at. Let's first take a look at some photographs of what we've got going here. CB199, 4.5 by 4, US 1D. US 1D, also, we're calling it 622, and that means 622 is the BHMA way of saying the finish. US 1D doesn't tell us the base material. We know that it's black, dull black, but we don't know the base material. You could use US 1D on steel or brass bronze, for that matter. But when we call it 622, that means it's made of brass. Is what that is. We'll take a look at that chart in a moment. Here's our hinge. This is the element right here and here that makes it a full mortise hinge. These bend on the leaves, these swags, these bends, that's what makes it a full mortise hinge. The back side of the hinge, Stanley does a very nice job finishing the back side of the hinge. Not every manufacturer does. When it's black, it's going to be finished on the back, but not in plated finishes. A little close-up view of what that finish looks like. It's, only representative based on the light that we have here. Stanley CB. That sure looks like a plain bearing hinge, but it is certainly not. Close-up of the logo, showing you how nice of a job they do on the finish in these areas. Backside, stating CB199. Your screw package, this comes with all machine screws and all wood screws. I can't say that that's standard. That's what they packaged in here. If we leave it up to guesswork, we don't know what the factory will send us. And by all means, declare what you'd like the factory to send. This part number that we ordered for the factory, from the factory, just specified standard fasteners. And apparently that is all wood screws and all machine screws. So if for every hinge that you order, you'll get 8 number 12 threaded to the head, flathead Phillips wood screws, and then 8, 12, 24 flat undercut head machine screws. Just a really great looking hinge, fit and finish. This only blemish here is just my fingerprints from manhandling it. Now, there is a link below this video to the template, or cut sheet it might be called. It should be called template. And let's look at the template. We're doing a CB199. That is a heavyweight. Well, it's non-ferrous, so it's in the non-ferrous column. Down here, it happens to be heavyweight. We know that by this, the 180. And then gives us all of the important dimensional properties. We're at 4.5 by 4, and our swag line, or edge of the leaf, to where the hinge bends is 1 in 15/32. That's the F dimension here. A lot of people like to know that, what that dimension is. 1 in 15/32. So it's helpful to know also where the location of the screw holes are. This is called the template pattern. This document we would call a template, but we'd also call it the template pattern for the location of the holes for the screws. If you're not sure if this will match what you're working on, by all means, double check. These are the locations. But if your door or your frame or your hardware is made to the template pattern, it will be this exact locations. There's a link also below this video to the cut sheet, and here it is. Actually, no, here it is, sorry. CB199, that means heavyweight, concealed bearing, made of brass or bronze. Here is the table, or the chart of hinges that they make. You see they don't list a 4.5 by 4. They will make it, but it's not on here. But it can be done, and thankfully so. We talked about that 4.5 by 4 versus some other width dimension. They can certainly do wider hinges. They can do 4.5 by 7 would be my guess, is the maximum width. Before we get to that, let's just talk about this. For use on heavy doors where high frequency is expected, entrance to office buildings, etc. Template hole pattern we talked about. Concealed life span, lifespan would be my guess. Bearing is maintenance free, no oil, no grease. Very clean look. You can tell though, because the barrel is a little bit thicker, I think. I've not put a caliper on a CB hinge versus a plain bearing hinge, but I believe this barrel would be a little bit thicker. Non-ferrous pin in this hinge would be stainless steel. Hole in bottom tip for easy pin removal. Should you want to drive the pin out, you can. There's going to be a small little hole down in that bottom button tip, and I'll show that to you, provided I don't forget. Reversible flush tips and pins. Why you might want to drive the pin out, because you want to attach the leaves to the door and frame and then bring the door to the frame and hang it that way. That's how I do it. So that's why you would end up doing that. Options you can do: raised barrel, electric hinge, monitoring, power transfer, hospital tips, decorative tips, security studs, non-removable pin. I don't intend to breeze through these and not explain them, but you know, those are topics for different videos. But I'm happy to explain these. Reach out to me if you can't find an explanation on these terms. I would be happy to do so. Now, the product catalog that's here is also this document that we happen to be in now, this 5-knuckle concealed bearing, and it goes on for about 10 pages. It allows you to scroll through and see all the important things about a CB hinge, and that's what the bearing construction looks like. Patented 2-piece bearing system. Makes for a very clean look. Discussed here. And if you recall, I had mentioned earlier about the client who was getting tagged on having a hinge that appeared to be plain bearing. Well, they go so far as to say that this hinge is approved for all fire doors. CB barrel matches the appearance of the F-line. Plain bearing hinges for uniform appearance throughout the building. I had just said it looks like the plain bearing. It might be a little thicker in diameter. I don't know that. It may be. Equipped for with easily seated non-rising pins. Non-rising and non-removable, two different terms. Non-rising simply means that there's a feature to the hinge pin that doesn't permit it without intentional effort to drive the pin out. It won't just extrude out. If you've ever seen a hinge pin that seems to be creeping up out of the top of the hinge, Non-rising pins work to prevent that, and they do in my experience. If you've got a pin that kind of just moves up like it's being extruded or pushed, that's not a non-rising pin. Non-removable pin means you can set the hinge barrel via a set screw here to prevent that pin from being driven out should you want to, like you would on an exterior door that swings out. So back to our table, 4.5, 4.5, up to 8 by 8. Let's touch on why you may want a different width than 4.5 inch. Well, here it is. DT minus HB times 2 plus I plus C. Door thickness minus hinge backset. 1 3/4 minus quarter is 1.5 times 2 is 3. Plus your inset, let's say that is 1/8 at the most. Plus your clearance, let's say that's 0. 3 1/8 is the answer, and the rule is you go to the next largest hinge of commercially available, and it would be 4 inch. So where did I come up with all that baloney? Let's go over it. I'll leave the formula. So let's do this. You've got a door. Your door swings out. You've got your hinge pin, your barrel. Here's your hinge. Okay. So the door thickness is literally just the door thickness. And I drew that all wrong. There's an area here where the hinge will not be mortised. That's the hinge backset. It's usually 1/4 inch on an 1 3/4 thick door. And you multiply that by 2. Now your inset, I'm going to get rid of all of this, is the distance from the face of the frame to the face of the door. Right there. It's usually about 3/32, or it can be 0. Or for that matter, if we were to change the scale of our drawing, or just change what we're doing here, it could be anything. Could be 1 inch, could be 9 inches. That's the inset. But generally it's a very small, negligible value. Less than 1/8 of an inch, or 1/8 of an inch, or 0, or it's some dimension. So you'd have to calculate that. Now clearance is, I went a little too far. Clearance is this. What does your door need out here from the jamb to the face of the door when that door goes to 180 degree? Okay, what's the clearance, the C? It may be 0, or you could have some chair rail. Pardon me, you could have some brick mold out here. Actually, might be drawn a little bit backwards. Okay, you might need to increase the width of the hinge because you have to account for this 3/4 inch. So if we ran the same formula with 3/4 inch applied molding, 3 inch for all of this, plus I, let's just say that that's 1/8 of an inch, plus 3/4. Well, now it's 3 7/8. You're still okay with 4 inch. But let's say that the clearance was now 1.5 inches. Now you see 3 plus 1/8 of an inch plus 1.5 inches. Now you're at 4 5/8, or 0 if this inset is 0. That it would be exactly 3 plus 0 plus 1.5 inches would be exactly 4.5. So depending on how you put the formula together, on what variables you plug in, that's what's going to determine it. But the important thing is, as I had said earlier, most installations, you've got a typical knockdown 3-piece drywall frame, metal studs, okay? Your favorite coffee shop, 4 7/8 wall. Well, sorry, there's drywall that needs to be drawn in here. Got to have some drywall, okay? Back bend returns. That door, there is no clearance. The inset is less than 1/8 of an inch. So you can go with that 4-inch wide hinge. So in a wraparound application on a steel frame, and there's no applied molding to the wall or to the raised molding to the door, yeah, 4-inch wide is what you want. And that's clearly what this client detailed. And that's where all that comes from. So pretty handy way to know how to calculate that. And then again, this table gets you there. Now, I don't think they're going to do a 5x4. They might. Some manufacturer will, I'm sure of it. And why you might want a 5x4 is because you are in this sort of scenario, but you have an extremely heavy or wide or very high frequency use. You'd go to a taller hinge. Same with 6x4.5. You know, you increase the height of that hinge, 4.5 to 5, 5 to 6. The capability of this hinge to handle the load gets substantially better every time. Now this catalog, actually let's back up. There is, close off some of these tabs here. There is a link below this video here to the manufacturer's page. And from here, you can pull up the entire Stanley catalog, which is right here. This is a very old catalog, old document. It's the one I like to use because I'm familiar with it, and I don't believe much has changed in the world of Stanley in the last decade. The first couple 3 dozen pages in the catalog are simply an encyclopedic discussion on hinges. And if you work in the door hardware industry or with hinges at all, you'll want to possess a working knowledge of everything in the beginning of the catalog. They discuss different types of hinges: full mortise, full surface, half mortise, half surface, swing clear, raised barrel, wide throw, all of these different concepts, anchor hinges, rescue pivots, things of that nature. Rescue pivots are probably in here as well. This is the formula from the Stanley catalog, what we just went over, shown a little more clearly. Different fastener types that you can do. Olive knuckle hinges are also in here. Now, we had said US 1D base material. So they're using 693 base material for all of these indicators. Let's go to under Contact Us, under Video Gallery, go to page 2, or at least at this time, and then do a find function on your keyboard for BHMA, and we'll find the BHMA finish chart. So 1D, so the chart that I have does not even list 1D in it. Let's see. There may be in the PBB finish chart. Yeah, they don't help much either. US 1D dull black. They don't give us a list for 622 at all. So let's go to the internet at large. BHMA 622 finish. All right, this chart. 622. Here it is. Flat black coated. They call it a US 19 here when it's a 622. Let's see if the Stanley book gives us anything. Let's see, US 19. Yeah, there it is. So calling it 622 would give us an equivalent of US 19, a flat black coated, and a 1D, which isn't in here if I recall, is a matte or a flat black. So playing a little fast and loose, I suppose, with that. But I used US 19 or 622 to tell the factory that I wanted a dull black or a flat black. I would say that those terms are pretty interchangeable. But to clarify that I wanted a base material of brass. US 19. Yeah, PBB does not have it either. Anyway, that's the point of what we were driving at. Okay, let's wrap up this video on camera. If you are enjoying this video, please click thumbs up or like, and also please consider subscribing to our channel. Let's move on to the rest of the video. Okay, so hopefully not forgetting anything. I did want to show you that little hole down in the bottom of the tip of the hinge that will allow you to drive that pin out. You're likely going to. A very small pin punch is what you would use for that. Okay, that's what I use. It's driving that material out is something you're going to want to be careful with. Generally, I will, depending on what I'm set up to do, I might put this onto the top of my vise, put some cloth down, turn it upside down, and then I will tap that down with my pin punch and then a mallet. I don't like to have a metal object hitting unintentionally the material itself. This has got a pristine finish with the exception of those fingerprints. Now the screws are here, complementary finish. The Stanley hinge box includes these cardboard separators. These are nice to keep the hinges from each other, but they're also shims, cardboard shims. It's permissible to use cardboard shims to shim your door. Why not? Have at it. You may need to shim the door a little bit. If it's a fire-rated door, which this clearly wouldn't be because the hinge is brass, you would not be using that cardboard shim. You have to use a steel shim according to NFPA 80. The name Stanley is synonymous with hinges and other hardware and has been since the mid-19th century. The name Stanley is also now, the term mixed up came to mind. They're connected together, woven together with many other companies. I believe that they're now under the Dorma-Caba name, and Stanley's sister companies would be Precision, Dorma, Best, countless others. I believe Best is going to be rebranded into the name Stanley, or I think Stanley hinges are going to be rebranded into the Best hinges. There you go. I don't make the decisions. I'll always call them a Stanley hinge. What is remarkable to me about that is there are hinge manufacturers who I will ask if they can make a hinge. They'll say we can't. Stanley has never told me that they cannot make a hinge, and I've asked them for some odd combinations of material. Number one. Number two, their material always comes back with very good fit and finish. In fact, it's my personal choice. If someone said, what's the best looking hinge? I'd say it's the Stanley hinge, is the bottom line. It's because I've reviewed lots of them, and I've never been dissatisfied with the quality of that fit and finish. Listen, it's just a hinge. No one thinks of it. Well, true, but that's not true. Lots of people think about hinges, architects, designers, owners, people paying for it. If you're a door hardware distributor like I am, a hinge is a hinge is a hinge. Well, it's not. And the fact of the matter is I want it to look as nice as possible as well, even though it's something that, on the back of the strip mall, no one's going to think about it. It just needs to work. It's awfully nice when it looks nice as well. Any questions on the CB199 concealed bearing hinge or any other Stanley product, please feel free to reach out to us. Thank you. Again, thank you for watching, and if you've enjoyed this video, please click thumbs up, please subscribe, and maybe even send the video to someone that you know. Thank you.